So we've looked at how to differentiate with powers of x. Now we're going to go a step further and look at how we can differentiate when we have negative indices or when we have powers of x in a denominator, which will also require us to deal with negative indices. So we're going to go through these 5 questions to give us a good understanding of how to solve or how to derive these sorts of expressions as well when we have fractions, as well when simplifying these fractions first, and getting them derived. So we'll go through them one by one, and you guys will sort of understand the different intricacies involved in each of these questions and how we can get past them. So if we look at the first one, we've got y is equal to 15x to the power of -4. Right now, if you guys remember, the same rule that we usually use when we have y is equal to, say, n to the power of x, or an to the power of x. I didn't write that again, sorry. So yeah, when you have a rule, if you remember the general, say if you have y is equal to an to the power of x, to derive that, y, the derivative of this would be ax n to the power of x minus 1. Okay, so you bring the indices to the front, multiply it with your already existing coefficient, and then the indices goes, you subtract 1 from that one. Okay, so we're going to do the same thing here. So over here we have y is equal to 15x to the power of -4. We get dy over by dx is going to equal, again, we're going to bring the -4 down. So we get 15 times -4. And then we have, I'll just put that in brackets just so it's clear. And then x, and then we have -4 minus 1. So 15 times -4 is -60. So -60x, and then -4 minus 1 is -5. So the derivative of 15x to the power of -4 just becomes -60x to the power of -5. Similar thing for the other questions though. B, now this one's a bit different because we've got x in the bottom here. So the way we derive this one is if you have x in the denominator, we would switch this to, so f of x, this is the same as -6x to the power of -1. Okay? And now we've got a similar situation to a formula here, which we can now derive with. So f dash of x is equal, again, we'll bring the -1 to the front. So we have -6 times -1, and x minus -1 minus 1. Okay? F dash of x is equal to that. So f of dash of x is equal to -6 times -1, which is just 6, x to the power of -2. Okay, looking at the third one, then same thing, we've just got a few more numbers here. So f of x is equal to -2 over 5x to the power of 5. Same thing, I want to get this x to the top, but we're going to leave everything else where it is, right? We're going to leave the 5 where it is. We're only going to bring this x to the power of 5 to the top. Okay, so in other words, f of x is equal to -2 over 5 x to the power of -5, right? We can rewrite it like that. And then, again, we've got the same formulas here, and we redo that. So again, I'll do it step by step. Just so you guys understand, so f dash of x is equal to -2 over 5 times -5. Right, so this power again, we just bring that to the front. And then we have x to the power of -5 minus 1. Okay, so -2 over 5 times -5 is just 2. And we've got 2x to the power of -6. Right, looking at question D, y is equal to, now we've got a bigger fraction here, 2x squared minus 1 over x. So again, whenever we have a fraction like this, we need to get rid of the fraction, right? Because we can't derive it as a fraction. So what we're going to do, we're just going to divide. We're going to split this up. So this is 2x squared over x minus 1 over x. Now we're going to simplify this and try to get rid of all of these fraction signs here. Okay, so 2x squared over x just becomes 2x. And we can rewrite 1 over x as x to the power of -1. Okay, now we can derive this. So this is our y so far. So our y, so yeah, dy over dx is going to equal to the derivative of 2x is just true. And then for this to derive this, we're going to bring a -1 to the front. So that becomes, there's already a -1 here. We just don't write the -1. So -1 times -1 becomes plus, and then we've got plus x to the power of -2. And then rewriting that, we'll get 2 plus 1 over x squared. Just because we just want to avoid having a negative indices in our answer, so we can rewrite all of these as well. So this will be -60 over x to the power of 5. This one will be equals 6 over x to the power of 2. This will be 2 over x to the power of 6. And then this will be 2 plus 1 over x to the power of 2. So you can see when we're rewriting it without negative indices, we're not bringing the entire thing down. Just the x, right? Just the x and its power and its associated power, right? The coefficient that will stay in the numerator. Okay, and then last one is e, which I'll do up here. We'll go 4x to the power of 5 minus 6x to the power of 3 plus x, and then over x squared. Okay, and sorry, forgot to write y is equal to. Okay. Y is equal to this. Okay. Now again, we're going to do the same thing to derive this. First, we're going to split this up into individual fractions and then simplify as much as we can and get rid of all the fractions there. Okay, so y is equal to 4x to the power of 5 over x squared minus 6x to the power of 3 over x squared plus x over x squared. Okay, now, well, if you simplify this as much as possible, 4x to the power of 5 over x squared is just 4x to the power of 3. This is just minus 6x, and this is plus x to the power of -1. Now we can derive this. So dy over dx is equal to 12x squared minus 6 minus x to the power of -2. Okay, and again, if we rewrite this 12x squared minus 6 minus 1 over x squared. Okay, and that's your derivative. So we've learned two things here basically. First thing we've learned is how to deal with these negative indices. And second thing is we've learned how to deal with fractions. So when you've got the fractions, you just split it up, simplify it as much as possible, get rid of the fractions, even if that means you need to get into a negative indice. And once they're done that, then we can derive those term by term.